I think that there's a right for people to know what's in their food.
We first raised GMO corn in 1997. We last raised it in 1998.
I've been growing corn since I was a little boy.
About 1973.
My name's Ralph Dorn, been farming for right at 30 years.
That's a long time, 40 years. And I've been raising pigs that long too, so I know what I'm doing.
Yeah, we probably eat GMOs in our cornflakes and breakfast cereals all the time, and whether we know it's GMOs or conventional corn, who knows? We don't have the capability of testing our breakfast cereal.
Now personally, I've been contacted by telephone and email by a number of scientists who have serious concerns about aspects of the research that is taking place in various institutions in New Zealand and the increasingly close ties that are developing between science and commerce, but who are convinced that if they express these fears publicly, even to such a commission as your own, as the Royal Commission here, or even if they ask the awkward and difficult questions, they will be eased out of their institution.
Accordingly, what has occurred at the FDA should not serve as a reason for other nations to approve GE foods, but rather as a strong reason to reject them. And I know these are serious allegations, and I would not make them unless the facts thoroughly back them up.
I think that the simplest analogy is smoking. How long do you think?
Well, what we learned about the GMO variety was that it was a lot healthier plant because it was resistant to corn borers, which corn borers come in and they drill at the shank of the corn, and the ear of corn will fall off before you can combine it. So you have a lot of yield loss when you have bad corn borers.
What is today's scientific definition of genetic engineering?
Well, the scientific definition of genetic engineering is very difficult because it's not a very precise concept. But what they understand under the term of genetic engineering is when you take a gene, put it in a construct or a vector, and transfer it to a plant to confer some potentially advantageous property.
GMO worked well for the corn borer resistance.
This is ironic. That on the one hand you take out a patent because your food is so unique that you're able to take out a patent which enables you to profit from it, but on the other hand you're able then in regulatory regimes to argue that it's essentially the same as a conventional food.
We've been feeding GMO corn since '97 in their inception, you know, under the market. I'd be what you call an early adopter.
Our whole problem was the fact that we were not getting sows pregnant. Whether they were conceiving or not, we don't know, but we just weren't getting them pregnant to where they would have baby pigs. And we run through all kinds of tests for disease problems, management, all kinds of stuff we checked, and we couldn't seem to put our finger on any one problem that would cause sows not to become pregnant after they were bred.
Got along fine with 97, 98, 99. The year 2000, I switched to a different company's genetics, and it was a Liberty Link, Cry9C. It was a Starlink hybrids, is the ones that I was using. They were Garst hybrids, there's no secret about that. We looked and we looked all through the normal channels, and it was a little more challenging because I've got a nutritional background. I had also had a nutritional consulting business for the last 20 years, so I was a little above the average as far as what we were doing, and I was working with a better than the average group of technicians with solving these problems.
So we got to talking with some other farmers, and we thought maybe there was something wrong with our feed as far as our corn goes. And other farmers had the same problem.
Well, we were having the trouble all the time, and one day we were out baling straw in the field, and Jerry Roseman come by. He said, "I heard you're having trouble with conception rates." Yeah, we are. Well, he was too, and he was doing a lot of testing of the feed, if it was mold or what it was, and At that time, I don't know for sure if he really knew it was the BT corn that was bothering or not, because it was so early in the stages. And, you know, he said, well, what are you guys doing? Well, we got fed up and was already halfway out of the sows.
My nutritionist was working things through from a toxin nutrition standpoint. My veterinarians were working from a diagnostic standpoint, looking for anything that we could think of out here, all the known problems. I mean, we were looking for the PRRS, we were looking for the leptos, we were looking for the virus diarrheas, the E. coli, anything that we could find, and we kept coming up negative. The nutritionist was the same thing. He said, you know, he said, from the onset, he said, this looks like it's a toxin problem. He said, it looks like a mycotoxin. He says, we see these occasionally. He said, I've done all the normal tests, and we've done some fairly sophisticated extra tests. He says, I can't find anything wrong here.
If you have a gene, it has to be first somehow taken into the nucleus of the recipient cell. It will have to tell that cell to start reading that gene, that DNA sequence. It also has to tell that DNA sequence where to stop. Then you also have to have something which will be useful for selection at the end, so that you can take out all those cells which have already been converted, and some sort of reporter, selection marker and reporter. So you have a minimum of something like 5 pieces of DNA which is going into a construct, and then you are using a means of a vector to transfer it into the recipient plant genome. So this is not a simple business of a single gene. It is a construct which will go in and which will be reading from the beginning to the end, and then be able to do the selection on this. So this is the simplest definition of genetic engineering.
The people who do this obviously understand what's going on, and the people who are trying to sell it, they may or may not understand what's going on, but it's clear that the technology does not allow you to be that precise. And the precision up to a point is there in the sense that you know exactly, usually you know, but not always, what you're making and what you're putting into the plant, but where it goes in and the downstream events from that are totally unknown for most purposes. And so the idea that you're just putting one gene in and getting one event out is totally false.
Well, we were running, at the time we quit, around about a 30% conception rate.
My failing rates have plummeted to 20%. And they just stayed at that level. They would bounce around a little, but they would consistently, they would be 20%.
Our problem was a little different than Jerry Roseman's, and we had a couple, I think 2 or 3 different companies' corn we planted. What we had was some Northrop King corn, along with our Garst and a little Pioneer corn. Some of the grain bins actually had different varieties of corn in it. We had some in one bin and some in another bin, and as you use out of one bin like 1 month and the other bin the next month, sometimes I was getting sow's bread and sometimes I wasn't. And then as that corn was feeding down through the bin, you'd get one variety maybe for a month as you were grinding, and then the next time when that would funnel down, then it would get to the other corn, and pretty soon you'd be feeding the other variety, and then you'd have some problems. So that's why I didn't recognize my problem to be real severe, because I was still getting some sows pregnant, okay? Some sows that would still have pigs and they had good litters. And then the next time, the next bunch of sows that I tried to breed never got pregnant.